We are talking about the cylinders experiencing stress. So here we have something like the internal and external. Something like this. We have this is the internal. Then this is the external. So we have D4 external, we have D4 external. So the radial stress is given by this equation, which represents the positive side. Then it represents this position. So the stress will be given here. Like here we have a radial stress of 32. Which is, then internal diameter is this, is the small d is this one. Then we have internal diameter of 110 here. We don't have the external one, so we are given the radial stress, radial, and then the hoop stress here. So we have the radial for internal, hoop stress for internal. Also we have the radial for external and the hoop for external. So the hoop is given by this equation. The hoop stress is given by which is here. So here we have the internal diameter and external diameter. So what we have this represents the external diameter, and then the hoop stress here it's 0. It's at the, here it's unknown. We have to calculate it if we want it. So it's given by this equation. So this represents the external diameter, this one. So this we have a value which is uncalculated, you see, but it's a negative value because it's on the negative side. We have this represents the external diameter. So this is the formula that we have for the cylinder. So this is for internal, this is for external. So here we are given the value for the internal. So the hoop stress is given as 39. So we're going to put 39. So what we have in common here, the value of A here, this A representing this, it's the same as the value of A. So if we get A here, we also have the same value. If we get B here, we also have the same value of B this side. So these are equal. The A for the internal is equals to the A for external and U for external, they are equal. So what we are looking for this and this one. Okay, before that we have to equate these two equations, because we are given the hoop stress and radial stress. So we can equate these two equations like this. Call this equation 1 for the hoop stress. This we are doing an internal one. Internal. We are using the internal side. So the hoop stress is with the negative, and then we're going to get square for internal. We call this equation 2. So we are going to add equation 1 plus equation 2. So when you add this and this, we are going to get the hoop stress plus radial, and then this one we're adding, we're going to get 2a. So this one, the sign are not the same, it will cancel each other. So that means the value of a is plus. Then when we get a, we're going to use one of the equation to find the value of b, because this one is given and this one is also given, which is 39n, but we do not have a, so we're going to add this one, divide by 2. Then the hoop stress normally it's with the negative sign. It's a negative, it's in this side, so if we can use it, this side is negative, representing by this, and this side is positive, so anything that is negative. So we're going to use to get the value of b, because we already have the internal is given, it's 110, and then this one we're going to get it from this one, and this one is given, and then we can solve for b, and then when we get b, we are going to use this equation to get the value of d. So we are going to use the external equation, which is radial stress is 0 in the outside, because according to what is given there, and then making d the subject of the formula, we're going to get something like, because we already calculated b and a, we're going to get our d from here. So let's check from the statement, we are required to calculate the thickness. So the thickness is this one, the difference between these two, but because it's a circular like this, we have to divide it by 2, because we're checking at this thickness. So we're going to subtract this and divide by 2, because it's the overall diameter. Diameter is from here, and then the inside diameter. So to get the thickness, we have to subtract the 2 and get this thickness, which is from here to here. So when we get this diameter, we're going to see this one is given and this one will be calculated from this one, and then that's how we